Another aspect that you might be given when you're answering these questions under our functions, we can be given where x is multiplied to f of x, can be multiplied to its inverse, it can be the derivative. Have you ever asked yourself how so that x is now compared with y? Because f of x, there we are talking about the y values. So we are comparing the y values and also the values of x. So the idea, guys, is still the same, just like before. For us to get values, it can be greater than, it can be less than 0. You just have to consider the product of the two, a positive and a positive, a negative and negative. This is where it is greater than 0. A positive to a negative, or a negative to a positive, where it is what? Less than, where it is less than 0. And do not forget the critical values, guys, when you are dealing with a normal function such as f of x or its inverse. The critical values will be the turning points. It will be the x-intercepts. The x-intercepts in that case. That is also, we're going to consider the asymptotes where they are applicable. You must use it, all right? Then for the first derivative, you must know always that the critical values, it will be turning points, all right? So you must consider the turning points. And for that function, sometimes there are asymptotes. You must consider the asymptotes as well. All right, this one, it's a must for you to consider the x value for the asymptotes. So it's direct like that. Just consider, is x positive? Is x negative? Is that first derivative a positive or a negative? The same applies to its inverse. All right, so we are given this graph, which we dealt with before, a similar graph. Then the question here was, for which value or values of x will x times f of x be less than what? Less than 0. X times f of x be less than 0. So meaning to say, we must consider negative. To get a negative, positive times negative, or negative times what? Or negative times positive. So what are the critical values? We're talking about f of x. So for f of x, we consider x-intercepts or the asymptotes, where our f in this case, it is a parabola, as you can see. So meaning to say, our critical values will be what? Will be the x-intercepts. So you're going to consider the x-intercepts for our f of x, all right? So this is our f of x, the x-intercepts at p and what? At p and q. That is where you're going to focus on. At p, the value there was -3. At q, at q here, the value was 1. All right, so those are the critical values that you're going to use. So we compare, all right, so let's compare here. And this is 1. So we are going to see we've got 3 regions, 1, 2, 3. All right. So x is easier because x is just going to look into the what? Into the line, the x-axis, to say are the values of x there positive or negative. So for x, we're not going to worry. We are going to worry about what? F of x. All right. So for our f of x, we can see that from -3, as we go to the left side, the graph of f is above the x-axis, meaning to say it is what? A positive. But the x values this side, they are what? The x values, they are negative. All right. From -3 up to 1, our graph is below the x-axis. Our graph is below the x-axis, meaning to say it is what? It is a negative. But we must be very careful because the x values, they are limited at 0. From -3 up to 0, our x values, they are negative. Up to 0, meaning to say we must consider also the line of what? X is equal to 0. Because from there, the values will be now positive for X. So our graph is limited to 0. Then we can move on from 0 to 1. From 0 to 1, we can see that our X values, they are now positive. But our graph, it is still below the x-axis. Our f of x, it is still below the x-axis, meaning to say it is what? It is a negative. From 1, our f is now found above the x-axis, meaning to say it is what? Positive. Where the x values are still positive. We are in the positive region for the x values we are comparing from the x-axis. So which region do we need? Where there is positive, negative, or negative, positive? We are going to see that those were this region 1, positive, negative, for the values of x that are less than -3. We are comparing x values. So therefore, x is less than what? -3. All right. Which other region do we have where there is a positive, negative? This one is negative, negative, meaning to say it is out. From 0 to 1, remember 0 there to 1, x values, the x values are positive, y is negative for the graph. So we also need this region from 0 to 1. So that's another solution. X can be greater than 0, but less than 1 in this region, but less than 1. All right. Then from 1, going this side, we can see that x is positive, y is positive. So we do not need this region. It is out. So this was going to be our solution. You compare like that. All right. So it's just a comparison, direct comparison. Do not even worry, guys. All right. So that was it. If we consider this one, there was a log as our graph here, and that was the value of k, which is 16. All right, this was 1. All right, so this is the graph of a log, which is our f. But the question here was, for which values of x will x times the inverse, take note, is the inverse, be less than 0, all right? So we need a condition where x times the inverse of f, the inverse of f is what? Less than 0, all right? This is f. What about its inverse? So the inverse, we're gonna have reflection of this graph in the line y is equal to x. Remember, a log changes to an exponential, so this swaps to the y-axis. Just swap the values. So meaning say y is equal to 1. You swap these values, so it's going to be 2 versus 16. 2 versus 16, 2 somewhere here, 16 maybe somewhere here. So we're going to have our graph limited to the x-axis. It was going to be something like this, all right? So that is what you're going to have. This is 1, and this is 2 versus what? 16, all right? Here, I just want you to know what you are dealing with, the inverse of what? Of f, all right? So that was it. So they're saying, what will be the x values when x times the inverse? So the inverse, it is just like the normal graph of f of x. So do we have the x-intercept? That will be our critical value. X-intercept. We do not have the x-intercept. So we just compare to this y-axis where x is equal to 0. This will be our critical value. Remember, from there, x on the left is negative, on the right is positive, all right? So let's compare. On the left side, x is negative, all right? But our graph here for the inverse is what? Above the x-axis, meaning to say it is what? It is a positive, all right? From 0, as we go this side, 0, 1, and so on, and so on, the x values, they are positive. Our graph of the inverse of f, it is still a positive. It is still above the x-axis. It is still positive. So which condition is going to satisfy what we need here, where the product of the two is supposed to give us a negative? So it must be positive to a negative, or positive to, or negative to positive. So which one satisfies? All right. So you're going to see that this region was going to satisfy positive, negative, where the x values are compared to 0, they are less than 0 on the left side. So therefore, x is less than 0. All right. If you check this other side, both are positive. The function is positive, which is the inverse of f, and also the x values are positive, so that cannot give us a solution. So this was just going to be our final solution. That is how you answer these questions. You just compare according to the graph. Where do we have x being positive? Where do we have x being what? Negative. So meaning to say the line y, our y-axis, or the line x is equal to 0 is very, very important. It is going to be part of the critical values in our consideration. We must consider to say that for the x values, the y-axis is very, very important because their x is equal to 0. So it differentiates our x values to say on the left side, our x values are negative. On the right side, our x values are what? Are positive. So that is, it is going to be part of the critical value for this x that we have. The critical values, the critical value is going to be what? The line x is equal to 0, which is what? Which is the y-axis. Just like that, which is our y-axis. So you must consider that. But for f of x, the inverse, you consider x-intercepts or asymptotes. So in this previous one, we're not having x-intercept. That is why we never referred to any x-intercept, the last one that we just answered. For the first derivative, you work with the turning points, remember, or the increase, to say the increase positive, a decrease is what? A negative. So we talked about this before, so you can look into examples that are similar to that. Where you do not understand, bring that question so that we can work on it together. So this is it, guys. Just revise as many questions. Do revision. As an individual, make sure that you do revision. Do as many questions before you sit for an exam. You must have covered a lot of question papers before that.